Welcome to Chemistry World. Today video about significant figures is a basic topic, basics in chemistry topic. Of course, in bridge courses also we'll discuss this topic, significant figures. And in this video or in this lesson or in this class, we'll discuss about how to identify significant figures and how to add additions, how to do subtractions, multiplications, divisions, rounding off, all the topics we'll discuss in this video. Once again, I'm saying addition of numbers, subtraction of numbers, multiplication of numbers, division of numbers, rounding of numbers, and significant figures. All these will be discussed in this video. That is significant figures. There are so many rules are there to discuss, to identify the significant figures. Directly, I'm taking one example. In that examples, all the rules will be included. No need to write, no need to discuss each rule separately. By taking one example, let me discuss all the rules, how to identify, used to identify the significant figures. That example is, I'm taking one example. In this example, all the rules which are used for identification of significant figures will be used. So let us see now that one. 0.005 006 700, like this one number is. Let us see what are the significant numbers here, that is significant digits here. Insignificant digits are first. Significant digits means, significant figures means the digits in a properly regarded measurements. Simply we can say the digits which have the value, a remarkable value, are used for measurements, experimental measurements, and some digits are not useful, are not we can say are not enough, are not required to say the experimental measurements. The exact digits which are required for experimental measurements, that digits we call as significant figures. How to identify that significant figures? We have some rules. All rules will be included in this example. By taking this simple single example, let us see all the rules. First one, any number or any digit which is 0 before the decimal point, before the decimal point, if any zero digit is there before the decimal point, if any zero is there, this is insignificant. We should not consider it as the measurable value. If a zero is there, if non-zero is there, that is significant. Non-zero means 1, 2, 3, 4, 5, 6, like that. If it is there, that is significant. If zero is there, that is insignificant. We should not consider that as a proper digit in the experiments. Insignificant. And the digits which are present, the digits are zeros after the decimal point also. These two also insignificant. These also we should not consider. If non-zeros are there, like 1, 2, 3, 4, that are significant. If zeros are there, immediately after decimal point, they are insignificant. Before decimal point, if zero is there, that is insignificant. After decimal point also, if zeros are there, they are also insignificant. And this number is non-zero is there, so it is significant. Any non-zero is there after decimal point, non-zero digit, apart from the zero, if any number is there after decimal point or before decimal point, after decimal point or before decimal point, that is significant. That is significant. So this number is significant. And these zeros, please be careful, these zeros which are present after non-zero digit, means after significant digit, if zeros are there, we have to consider these as significant. These are not insignificant, please. If zeros are there after non-zero, before the digit or after the decimal point, before the decimal point or after the decimal point, if zeros are there, they are also significant. Remember, if I write one non-zero here, this also becomes significant. If non-zeros are not there, only zeros are there, they are insignificant. So any zeros which are present after non-zero digit, they are significant, or any zeros which are present before non-zero digit, they are insignificant. Before decimal point or after decimal point, this is one rule. So this example is enough, that's what I'm saying. And these are also non-zeros, so significant. These are significant. 6, 7 digits are significant because they are non-zeros. They are significant. And after that, these zeros also significant. These are also significant. Why? Because these are present after non-zero digits. If zeros are there after non-zero digits, definitely they are significant. So here, this is insignificant, this is insignificant, but this is significant, this is significant, this is significant, and this is all are significant itself. So this example is more than enough to identify significant figures. Once again, I am saying, if non-zeros are present here before decimal point, non-zero like 1, 2, 3, 4, 5, 6, 7 up to 9, they are significant. If zeros are there, insignificant. Before decimal point, if non-zeros are there, significant. If zeros are there, insignificant. After decimal point, if non-zeros are there, means 1, 2, 3, 4, significant. If zeros are there, insignificant. If non-zeros are there, significant. If zeros are there, insignificant. And here it is non-zero, automatically it is significant. And these are zeros which are present after non-zero, that's why these are significant. Means if zeros are there after non-zero digit, that zeros also becomes significant. If zeros are there before non-zero digit, they are insignificant. Zeros are there before non-zero, insignificant. Zeros are there after non-zero, significant. And these are non-zeros, definitely significant. And these zeros are present after non-zero digits, so these are also significant. In Telugu, somebody is requesting to say in Telugu, so మళ్ళీ చెప్తున్నా చూడండి జాగ్రత్తగా, తెలుగులో కూడా చెప్తున్నా. సిగ్నిఫికెంట్ ఫిగర్స్ డెసిమల్ పాయింట్ ముందర జీరోస్ కాకుండా వేరే నంబర్స్ ఉంటే, లైక్ 1, 2, 3, 4, అవి సిగ్నిఫికెంట్. జీరోస్ ఉంటే ఇన్సిగ్నిఫికెంట్. డెసిమల్ పాయింట్ తర్వాత నాన్ జీరోస్ ఉంటే సిగ్నిఫికెంట్. జీరోస్ ఉంటే ఇన్సిగ్నిఫికెంట్, అంటే కన్సిడరేషన్ చేయకూడదు. నాన్ జీరోస్ ఉంటే అది బిఫోర్ డెసిమల్ పాయింట్ కావచ్చు, ఆఫ్టర్ డెసిమల్ పాయింట్ కావచ్చు. నాన్ జీరోస్ ఉంటే సిగ్నిఫికెంట్. నాన్ జీరో తర్వాత మళ్ళా జీరోస్ ఉంటే, నాన్ జీరో తర్వాత ఆఫ్టర్ నాన్ జీరోస్ తర్వాత మళ్ళీ జీరోస్ ఉంటే అవి సిగ్నిఫికెంట్. నాన్ జీరో తర్వాత మళ్ళీ జీరోస్ ఉంటే సిగ్నిఫికెంట్. ఇవి నాన్ జీరోస్ కాబట్టి మళ్ళీ సిగ్నిఫికెంటే. నాన్ జీరోస్ తర్వాత మళ్ళీ జీరోస్ ఉన్నాయి కాబట్టి ఇవి కూడా సిగ్నిఫికెంటే. అంటే ఇన్ దిస్ ఎగ్జాంపుల్ హౌ మెనీ సిగ్నిఫికెంట్ ఫిగర్స్ ఆర్ దేర్ అంటే, ఈ ఎగ్జాంపుల్లో ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ ఉన్నాయి అని అడిగితే ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ ఉన్నాయి అని అడిగితే ఆన్సర్ ఈస్ ఇఫ్ దే ఆస్క్ ద నంబర్ ఆఫ్ సిగ్నిఫికెంట్ ఫిగర్స్ ఇన్ దిస్ ఎగ్జాంపుల్, ఈ ఎగ్జాంపుల్లో ఎన్ని సిగ్నిఫికెంట్ ఫిగర్స్ ఉన్నాయని అడిగితే, సో ఇది ఇన్సిగ్నిఫికెంటే, ఇది ఇన్సిగ్నిఫికెంటే, ఇది ఇన్సిగ్నిఫికెంటే, ఇది సిగ్నిఫికెంట్, ఈ నుంచి అన్ని నంబర్స్ సిగ్నిఫికెంట్సే, అంటే అన్ని డిజిట్స్ సిగ్నిఫికెంట్సే. సో కౌంట్ చేస్తే 1 2 3 4 5 6 7 7 డిజిట్స్, 7 డిజిట్లు, 7 digits are significant. So number of significant figures in this example are 7. Number of significant digits in this example are 7. Like that you can go for any example. You can go for any example. So please be careful for this significant figures. Once again I am saying, by going back in this video, please see how to identify significant figures and how to write significant figures in this example. This is significant figures. Now coming to addition and subtraction of significant figures. I think you understood this one. You can take one more example. I'll explain with one more example. If 0 point, example 2 is there, 0.000760, if it is there, in this case this is insignificant, this is insignificant, this is insignificant, this is only significant figures are this. So in this, the number of significant figures, if we write, they are 3 only. ఈ ఎగ్జాంపుల్లో సిగ్నిఫికెంట్ ఫిగర్స్ అడిగితే ఎన్ని ఉన్నాయి అంటే, ఇది ఇన్సిగ్నిఫికెంటే, ఇది ఇన్సిగ్నిఫికెంటే, ఇది ఇన్సిగ్నిఫికెంటే, ఇది ఇన్సిగ్నిఫికెంటే. సో దీస్ 3, ఈ 3 మాత్రమే సిగ్నిఫికెంట్. సో నంబర్ ఆఫ్ సిగ్నిఫికెంట్ ఫిగర్స్ ఇన్ దిస్ ఎగ్జాంపుల్ ఈస్ 3 only. And if I write this example as like this 0.0, say another example I am taking, example 3. Example 3 I am taking 0.007600, if it is there, 0.007600, if it is there. Now in this case, how many significant figures are there? According to the rules what we have discussed here, if we amplify, if we apply in that, ఈ రూల్స్ ను బేస్ చేసుకొని దీనికి సిగ్నిఫికెంట్ ఫిగర్స్ చెప్తే, ఇఫ్ we say that one, this is insignificant, this is insignificant, insignificant, and these 4 are significant. So here the significant figures are 4 in number. There are 4 significant figures in third example, because the zeros after non-zeros become significant. The zeros before non-zeros are insignificant. So these are insignificant, these are significant. These are automatically non-zero digits, so significant. You can take like that. And I'm taking one more example. One more example, number 4, 0.076060, if it is there. Let me count number of significant figures in this case. ఇప్పుడు దీంట్లో చూద్దాం. This is insignificant, this is insignificant, and these all are significant. So because if the 0 is present between non-zeros, that is also significant. I wrote here significant. Zeros between non-zeros and zeros after non-zeros, significant. Zeros before non-zeros, insignificant. So this is insignificant, this is insignificant, and all these are significant. So number is 1 2 3 4 5. Number of significant figures in this example are 5. And if I write example number 5, only one number I am taking, I am writing significant figures here. Suppose if 760.500 is there, or 68 if it is there, like this, and 0 also. Let me write one more. In this, how many significant figures are there? How many significant figures are there? If you see that one, this is significant because non-zero. This is significant, so non-zero. This is significant because it is zero after non-zero. This is zero after non-zero, so this is significant. This is significant, this is significant, this is significant, 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 significant. All digits in this example are significant because no zeros before non-zero. Maybe that is before decimal point or decimal point. So answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. In this example, all these are significant figures. So number of significant figures in this example is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 significant figures are there. Like that, you can take any example to identify significant figures. This is the best example. One example is enough to explain all the rules to identify significant figures. This is next topic in this video. Let me go for addition and subtraction of significant figures. Addition and subtraction of significant figures. Let me go for that one. Addition and subtraction, very important and very useful to everyone. This video, those who have the goal to get IIT seat, NEET seat, NIT seat, a top engineering college, or in any top courses, these significant figures are must, both in physics as well as chemistry, because in physics also we have significant figures, in chemistry also we require significant figures. So that's all. Now let's go for addition or subtraction. Addition of significant figures. How we have to do addition? Addition of significant figures. How to do significant figures in this case? Let me see now. First, let me take some example. By taking example, we need to discuss about addition of significant figures. Let me take the example. Where is the addition? Where is the addition? Let me take one addition example. Yeah, I'm taking example. Based on that example, let me see 4.23, 2.6, 32.506, 325.0678, if it is there, which on addition we get some value, but that value is not wrong. So in this addition, we have to know the rule. As in the final, we have to know the rule. We should know the rule. What is that rule means? What is that rule means? On after addition, in the final result, after addition, in the final result after addition, number of significant figures, after decimal point. Before decimal point, any number may be there, any number of digits may be there, no need that one, no consideration. But after decimal point only, after decimal point should be least number, of digits, after decimal point. Before decimal point, whatever the number of digits may be there, that is okay, but after decimal point, the number of significant figures should be least. Means here After decimal point, we have two digits here. After decimal point, we have one digit. After decimal point, we have three digits. After decimal point, we have four digits here. Here 1, here 3, here 2, here 4 are there. If we sum up this one, what we get? 8, 6 plus 7, 13, 6, 1, 7 plus 0 plus 3, 10, 1, 6, 12, 14, then decimal point, 6 to 8 to 10, 14, 3, 4, 6 and 3. So this is the value we have. 364.4038 we are getting addition value, but this is wrong perception, this is wrong explanation, a wrong representation we can say. According to significant figures, it is wrong representation. We should not write this as the correct answer. So here the correct answer is, already I told you, in the final result after addition, number of significant figures after decimal point should be least in number. In these values, which one has least number of digits after decimal point? This one. How many digits are there? Only one digit is there. So in the answer also, in the final result also, only one digit should be there. Only one digit should be there. Only one digit should be there after decimal point. Before decimal point, whatever may be the number, but after decimal point, must and should only one digit should be there. It should not be more than one. Why? Because in these values, this one has least number of digits after decimal point. So in the final also, only one should be there. So for that, we have to do a rounding off. To get one digit after decimal point, we have to round off these four digits into one digit. We have to round off. So round off is very, very important. Please be careful. Round off is very, very important. How we have to do that round off means, if any number is there more than 5, that should be, and before digit should be increases by 1. If any number is more than 5, before digit should be increased by 1, means this 364.4038, after rounding of one digit, it becomes 364.404. Why? Because this is more than 5 is there, so we have to increase one digit. అంటే తెలుగులో ఏదైనా నంబరు 5 కంటే ఎక్కువ ఉంటే దాని ముందు నంబర్ని ఒక డిజిట్ ఇంక్రీజ్ చేయాలి. దట్ బిఫోర్ నంబర్ షుడ్ బి ఇంక్రీజ్డ్ బై 1. ఇఫ్ దట్ నంబర్ ఈస్ మోర్ దెన్, ఏదన్నా నంబరు 5 కంటే ఎక్కువ ఉంటే దాని ముందు నంబర్ ఒకటి ఇంక్రీజ్ చేయాలి. సో ఐ ఇంక్రీజ్ దట్ వన్. సో దిస్ 38 becoming 4. 38 becoming 4. And this is not enough in the final answer. Why? Because final answer should have the only one digit. Here 3 digits are there. So 2 more digits we have to reduce. We have to round off. So here 4 is there. So it is less than 5. No need to increase any number in the before digit. ఒకవేళ ఏదైనా నంబరు 5 కంటే తక్కువ ఉంటే దాని ముందు డిజిట్లో నంబర్ని ఇంక్రీజ్ చేయాల్సిన అవసరం లేదు. If any digit which is less than 5 is there, to round off that one, before digit should be as it is. No need to increase. So this 40 becomes 0. Then it will be 364.40. Still it is not correct answer. We have to do one more rounding off. Why? Because in the final answer only one digit should be there after decimal point. So here we have to round off one, but there is 0 is there, 4 is there. 0 means less than 5. It should be as it is, means 364.4 is correct answer. This is wrong representation and this is correct representation. Correct representation, like this we have to do. Itla manam round off cheyali. బిఫోర్ డెసిమల్ పాయింట్ కంటే ముందు ఎన్ని నంబర్స్ ఉన్నా మనకు అవసరం లేదు. వీ డజంట్ రిక్వైర్ దట్ నంబర్, వీ నో నీడ్ టు రౌండ్ అప్ దట్ వన్. ఇన్ అడిషన్ ఐఎమ్ సేయింగ్ సో నో నీడ్ టు డూ. But after decimal point, we have to round off to least number of digits which are present in the given values. ఇచ్చిన వాల్యూస్లో దేనికైతే లెస్ నెంబర్ ఆఫ్ డిజిట్స్ ఉన్నాయో డెసిమల్ పాయింట్ తర్వాత ఫైనల్ ఆన్సర్లో కూడా అంతే నంబర్ ఉండాలి. ఇన్ దిస్ ఎగ్జాంపుల్స్ దిస్ వన్ హ్యాస్ ఓన్లీ 1 digit after decimal point. So in the final answer also only 1 digit should be there after decimal point. So I wrote this one. This is addition of significant figures. Next video, let me see subtraction, multiplication, division. Thank you.